Another way to estimate the variability of a statistic is a technique called bootstrapping, which allows us to approximate a sampling distribution and estimate the standard error using just the information from that sample. So ideally, we like to sample repeatedly from the population to create a sampling distribution. So how can we make the sample data look like the data from the entire population? Well, the key idea to bootstrapping is we start with our sample and then we pretend we make many copies of that sample. So we're kind of pretending we have our population. And if we make lots and lots of copies of the sample and then sample repeatedly from this hypothetical population, we are coming as close as we can to mimicking the process of sampling repeatedly from the population. So in practice, instead of making many copies of the sample and sampling from that, we use a technique called a sampling technique that is equivalent. That is, we sample with replacement from the original sample. That is, you could pick something from your sample, and there's always a possibility you could pick that thing again and again and again. Each sample selected in this way with replacement from the original sample is called the bootstrap sample. Since we're trying to capture the variability of the sample, we call the standard error, it is important that each bootstrap sample is the same size as the original sample. So if our original sample had 20 objects, then our bootstrap sample should also have 20 objects. For each bootstrap sample, we compute the statistic of interest, whether a mean or a standard deviation or a median or whatever. We call that the bootstrap statistic. We then repeat this many times to build up the bootstrap distribution. Anyway, the variability of bootstrap statistics is like the variability from sample statistics if we were to sample repeatedly from the population. So we can use the standard deviation of the bootstrap distribution to estimate the standard error of the statistic. If the bootstrap distribution of a sample statistic is symmetric and bell-shaped, we can estimate the 95% confidence interval using this formula of point estimate plus or minus 2 times the standard error, where SC stands for the standard error of the statistic estimated by the bootstrap distribution. If the bootstrap distribution for a sample statistic is not symmetric or bell-shaped, we can instead use the percentiles of the bootstrap distribution. That is, we want the middle 95%, so we're going to cut off the bottom 2.5% and the top 2.5% of the data. So, before we get there, let's just start with a simple example. Suppose our sample had 5 values, 2, 6, 8, 9, and 10, which altogether comes out to be a mean of 7. Now, imagine putting each of those values in different cards, shuffle those cards, and then draw. One example of bootstrap sample would be like 6, 2, 6, 10, 9. So you see that the 6's occurred twice. The 8 didn't occur at all. But this new bootstrap mean is a 6.6. Now I might try this again. And now suppose I get 2, 10, 8, 9, 8. This comes out to be a bootstrap mean of 7.4. I can do it again. You see 9, 8, 9, 10, 9. That's a bootstrap mean of 9. I can do it again. I get 2, 10, 2, 6, 8. Bootstrap's mean is 5.6. So I take those 5 cards I draw with replacement. So sometimes I'll get some values will repeat, though it doesn't have to. All right. So an example here. Suppose the original sample were the 5 numbers 1, 6, 8, 9, 10. So which of the following are possible bootstrap samples? Well, part A had the numbers 6, 11, 10, 6, and 6. That is not going to be a bootstrap sample. And the reason for that is the number 11 was not in the original sample. 811 is not a bootstrap sample, though it could be if you did a little bit more. 8 and 1 are both in the original sample. It's just that this sample is too small. I just need to draw 2 more times. 6, 1, 10, 1, 6. All those numbers are in the original sample. It matches the sample size. This is a Bootstrap sample. Or this is a possible Bootstrap sample. 6, 10, 6, 8, 9, 1. That is not, but if you just eliminated if you eliminate one of those numbers, it is a possible Bootstrap sample. This one just has too many values. And the last one, 1, 1, 1, 1, 1. Well, it doesn't look particularly random, but technically it could happen. So this is a possible Bootstrap sample.